is a squared minus 4. You see that on your paper there? So this is what's called difference of squares.
Difference of squares, okay.
And
So
the square,
difference of squares, so difference of squares simplifies to the factoring, right?
it's like another type of factoring. So it's as if because there's like a couple different ways, a couple different types of factoring that you'll need to learn, and this is just another one of them. So the way it works is that you have to write each thing as something squared. So do you see how 2 squared gets you back to 4?
Yeah.
Okay. So the difference of squares, it's a formula. We do have to write the formula. It's a minus b, a plus b. So in your problem, this is a, and then this 2 is b.
Okay.
So for example, a squared minus 4 ends up being a minus 2, a plus 2. It's a because you have a squared, and it's 2 because 2 squared gets you back to 4.
I know. Okay.
Now we'll do another one just like it here. Question 6 is also a difference of squares. So let me snip that in.
Okay.
And this is just like the previous problem. So what number squared gets you to 64? So like what number, when you multiply it by itself, gets you back to 64?
8.
8. Perfect. So again, our goal is always a squared minus b squared. And it becomes a minus b, a plus b. So in your problem, this is a, x is a, and 8 is b.
Yeah.
So this becomes x minus 8, x plus 8. Do you follow that? Do you see how it becomes x minus x plus?
So how is it a positive? Why is there a positive?
It's just the way the formula goes. Like there's always one that's negative, and then there's always one that's positive.
Okay. Okay. All right, got that. Okay.
All right, so let's move on to another one here. I'm gonna try and do them in an order that's best here for you. So let's see here. All right, let's look at 13 next. We're gonna come back and do the others, but
yeah, I know.
Start with this one here. All right, so 13, the game here is you got to figure out what's squared minus what's squared. You have to put something in each of these positions to get back to the previous line. So for example, what number when you square it is 25?
Okay, so for that,
so like what number when you square it gets you back to 25?
yeah, 5.
Good. Okay, now what number when you square it gets back to 4?
2.
Okay, and then to get back to x, to get x squared, you need an x here.
Okay.
So this is a, and this is b.
Okay, let me write that down. Okay. Here we go.
Okay, so
Got
you're,
it.
so the answer though is 2x minus 5. And then it's the same thing, but this time with a plus, 2x plus 5.
Okay.
All
Okay.
right, so
here
we're,
we
so
go.
we're gonna do 14. 14 is really similar.
Okay.
So all the ones we've done so far are this a squared minus b squared, and that's what I'm trying to get you to work through. These would be the ones that we would do next in terms of like learning factoring. So something squared minus something squared has to get you back to the previous line.
Yep.
So what squared gets you back to 9?
3.
3, perfect. And what squared gets you back to 64?
8.
Okay. And then x squared gets you back to x squared. Okay. So that again, it's a squared minus b squared. You write the next line below it, a minus b, a plus b. So this time it's 8x minus 3, 8x plus 3.
Okay. I'm writing it down. I'm writing it down.
Sure.
Okay, got it down. So it's 8x minus 3 and 8x plus 3.
That's right.
Okay.
All right. So the next problem we'll look at is 15.
15. That is very easy.
It has an additional step to the ones that we've just done.
Okay.
So the first
Yeah,
first
so that right there, 15.
the
Yeah.
first step here is actually to factor out the greatest common factor. And the greatest common factor is a number that divides both of these. So do you see how 8 goes into both of these? They can both be divided by 8.
Oh, yeah.
So 8x squared divided by 8 is just x squared. 72 divided by 8 is 9. Do you see that?
Yeah. Yeah.
Okay. And then now this part inside parentheses, it's kind of like the previous problems we've been doing. It's a difference of squares. It's x squared minus 3 squared.
Okay.
So again, it's a squared minus b squared.
Okay.
And that becomes a minus b, a plus b, but we're just focused on the part inside parentheses. So that's x minus 3, x plus 3.
Okay. All right. Okay. I'm just writing it down.
Okay.
Oh, I dropped my pencil. Okay. I got it down. Got it down.
All right. You got it all down? All right, perfect. So
Uh-huh.
let's move on to the next problem here. So we'll go to 16.
16, okay. 16, that, it, right there, it is,
So this one also has a greatest common factor.
the greatest common factor.
So it's the biggest number that divide both. So see how this is divisible by 5 and this is divisible by 5.
Yeah,
So it put 5 on the outside, and then it's 4x squared minus 1.
okay,
Okay, so now the part inside parentheses is difference of squares again. It's
okay.
something squared minus something squared. So what number squared gets you back to 1?
So what square gets you back to 1?
Yes, what number when you square gets back to 1?
1,
How about to get to 4? What number do you square? to get
2.
2. And then you need to put an x inside the parentheses also, so it's 2x. And again, it's a squared minus b squared, so it's a minus b, a plus b.
Here, let me
So-
write this down, hold on.
Sure.
Okay, so that is the answer.
Oh no, we're not quite there. We're almost there.
Okay, all right, so now, got it. I got it. Can we move on to the next answer?
Yeah, so
and-
again, it's a minus b, a plus b. So what is your a this time?
The A is 2,
2x. And what is your b?
1.
1. So it becomes 2x minus 1, 2x plus 1. Then you bring the 5 down.
Okay. Okay, got it down.
All right, so let's look at 10.
So 10, okay. 10, okay. That, so for 10,
So what number divides both of these? So you try the smaller number, like does 6 go into both? And it does. Okay, so 6x squared divided by 6 is x squared, and 96 divided by 6 is 16.
okay.
So this is again difference of squares. Do you see how 16 is really 4 squared?
Yeah, I can see that it is, it was, divided into the least common multiple.
Yes, we're finding the greatest common factor and we're dividing it.
Yeah, I know.
Okay, so now you have to write this as x minus 4, x plus 4. We're using the same formula every time, a minus b, a plus b.
Okay. Okay.
Let me know when you get all that down.
Okay. I know. Okay, so and then it equals 6. Okay, there we go.
All right, let's do number 7 next.
Okay.
So notice that 4 goes into both of these.
Yep. Okay.
So you can put 4
That
on,
right there, I know that. What does that equal? Or oh,
right? You divide both of them by 4.
yeah, I know.
So
Okay.
my question to you is, and this one's different, is 3 a perfect square? Like, what do you square to get 3? Can you
Okay.
square anything to get 3?
No, you there. It's nothing equal to the. There's no square root of
Right.
3.
So this is actually your last step. This is done.
Yep. Okay.
This is it. There's nothing else to do on this problem.
Okay.
All right, so we've got a few problems left here. Let's look at, I guess.
I'm gonna be writing that. Let me write that down first.
Okay.
So, so yeah, that's just only the answer 4, parentheses x2 minus 3. That's what
right.
it is. Because
Well,
there's
no,
no square root.
this is it. Yeah, this is your final answer for that one, because there's no way to use difference of squares with it.
Okay. Can we go on to number 3?
Yeah, 3 and 4 look like they're the next 2 to work on. So these are a different type of problem. They're called a perfect square trinomial.
Okay.
So this is what's called a perfect square trinomial. So it's
Okay.
a squared b squared plus 2ab. Right, so this one's different, but it still's got this a squared and this b squared. Do you see that?
Yeah.
So what number squared gets you back to 9? Like 3, right? 3 squared gets you to 9.
Okay. Yeah. Yeah.
And then x squared gets you back to 9x squared.
Yep. Okay.
So what squared gets you back to 25?
Okay. So, and that's 5.
That's 5. Now, the perfect square trinomial,
Yeah.
it's written like this. It's written as a plus b squared. So this time you write it as your a is 3x plus your b, which is 5 squared.
Okay. And that's the answer.
That's it.
Okay, I got it. Okay.
All right, so this one is also a perfect square trinomial. It's a squared
Okay.
minus
So
2ab plus b squared. And you want to figure out, well, what squared gets you back to this? And then what squared gets you back to this?
okay, that right there is okay, that is parentheses of 6x
Perfect.
of 6x minus
Well, then just what does this become?
and
Square?
minus okay plus a 2.
That's right. So this is the form right here. It
Yeah.
becomes a minus b squared this time. So this time it's a minus this b. So 6x minus 2 squared.
Okay. So yeah, I got the answer.
Yeah, that is it for the last line there.
Okay, now the bottom explain why are these, okay.
So we got 17 and 18 or 17. Let's do 17.
Okay.
Okay, so 17 is what's called sum of squares.
Okay.
And you just say this is not factorable. If this were a minus instead of a plus, it would be.
Okay. So
Would be.
some squares, this is not factorables for number 17, right?
Yeah, that's all you have to say.
Okay. And for 18, this right here is factored.
This one it's very similar to the ones we were doing the other night. We actually just have to take that last number 36. Okay, and write out all the numbers that multiply to 36, like 2 and 18, 3 and 12, 4 and 9, 6 and 6. Do any of these, and actually they're all negative here. Do any of these add up to negative 14? Like -1 plus negative 36 is negative 36.
No, none of them.
No. So I'm just writing it out here. You would say none of these add up to negative 14.
Okay. So, okay, not factorable. Okay. Yeah, because they do not add up to negative 14 because
That's right.
we
They just don't. There's none here that do.
yeah. Yep, okay.
All right. So number 19.
Yeah.
Okay. So let's go to, it says to go back to question 6.
And 13. Okay, well, that's what we just have right now. We just have, okay.
Okay, so this is for number 6.
Okay, so we'll just be able to just make find the
And then,
x-intercept.
yeah, it wants the x-intercept. So the x-intercept, and this is I guess it's something new. The x-intercept is when you set this equal to 0.
Yep.
Okay, so when you set it equal to 0, one way to do it here is to add 64 to both sides. So you have x squared equals 64.
Yeah.
And then to undo the square, you take the square root of both sides.
Okay.
So x is plus or minus the square root of 64. What is the square root of 64?
8
Plus or minus 8, actually.
plus.
When you take a square root, there's always a plus or minus.
Yep. Yeah, they're supposed to be. Yes. Okay.
Okay.
So, all right.
So these are the x-intercepts.
Okay. So the x-intercepts are these, right?
Yes.
And for 13.
It does say to sketch a graph, though.
Okay.
So the intercepts are where it hits the x-axis. So over here at -8, I'm sorry, +8, 0. Do you see that it's going to hit there?
Yeah.
And then same thing here at -8. 1, 2, 3, 4, 5, 6, 7. So -8 comma 0. All right, but we don't need to be that precise. We could actually just go ahead and sketch something that looks a little bit better. The graph looks like this,
Okay, yeah,
where this is -8 comma 0, and this is 8 comma 0. Okay, but it also wants you to find the vertex. So the vertex is down here. It's 0 comma -64.
okay,
Is that okay?
yep, that's good.
So make sure you get this graph down,
Yeah, I got the graph down.
and you got this work down also. Is that right?
Yeah,
Okay. So let's go back and look 13.
okay,
So 13. It says 4x squared minus 25. And the first thing we find are the x-intercepts. So you do this by setting it equal to 0.
okay. Okay, so I have to write it down.
Yes.
Okay.
It's part so close.
All right, so
That's-
now for that, we have to add 25 from both sides, and then
That's right.
So 4x2 equals 25.
Then divide both sides by 4. So x squared equals 25 over 4. And then the last step here is to take the square root of both sides.
Yeah.
Okay, so this time you can actually take the square root of the top and the square root of the bottom.
Mhm. Okay.
Okay, so this is really plus or minus 2.5.
Okay.
So again, it's like there's one here at 2.5 comma 0.
All right, got it down.
And then there's another one here at -2.5 comma 0.
Yep. All right, so
And then this is 0 comma -25. So you want to make sure you get these 3 points down on your graph.
okay.
All right, so we got some time left here. Do you want us to continue working
Oh,
on some of
hold
this?
on, I need to finish this.
Okay.
Okay, I think we're done because I got everything in my things, and I think we're done.
Yeah, if that's the case, go and ask your dad
Yep.
if he's okay with us
Dad?
ending here.
You want to come here? Okay, thank you, Matthew.
You're welcome.
Yes.
Hello, hi.
Hey, Dr. Kiyotari. So we got through everything on this worksheet here. I definitely would like to do some more practice with him if he's available at some point, but I appreciate you guys being patient with me tonight. Just had to deal with a personal matter and all good now.
No problem. Okay, so yeah, so we'll see you next week at 7 o'clock. 7 is good actually. 7 o'clock. Okay.
Yeah, so we'll be back to our usual schedule next week, and
Yeah.
just keep going here. We're heading towards spring break, heading towards the end of the school year.
Yeah, I don't know whether you want to do in spring break too, Sourish?
Spring break, and no.
Huh?
When is his spring break?
I'm March 21st to 25th, I would say.
Okay, so we got a couple weeks still before that.
Yeah. Yeah. So I think the usual schedule is 7 o'clock, right? We'll do 7.
Yes,
7
we'll
p.m.
keep the 7 o'clock. We'll be back to
Yeah.
our usual schedule, and
Yeah.
thanks so much, guys.
Okay, thank you.
Have a great night. Bye now.
Bye.